were actually not making the next step to full deployments because the batteries. They love the technology, love the products, but the batteries was getting in the way for the final rollout. So I thought I'll dedicate my speech here working for Dracula Energy Harvesting from a perspective of how can you reduce your TCO when you skip the batteries. So the first of all, of course, the sustainability aspect is batteries. 50% of batteries are not disposed properly. This is a study from the EU called the Cordis Working Group. So 50% of all batteries end up in normal waste, which is just not sustainable. And if you think about the IoT forecast, where we talk about 30 or 40 billion devices in a couple of years, it's just unimaginable how many batteries will go just down the drain, right, and end up in nature or some sort of unrecyclable waste. I'll talk about the total cost of ownership later in my speech, but also the thing I want to point out is process continuity. There's certain business clients and enterprises that want to rely on the data completely, right? They cannot afford a discontinuation of the data stream from a sensor. So if a battery goes down, which is going to happen, as we all know, you're going to lose that stream of data, which can be really posing an issue. And last but not least is regulatory compliance. There's really regulation building up, particularly in the EU, where this is going to come down on every country to make sure when new buildings are being built, these buildings have to comply with this new so-called EPBD, so Electricity Power Business Directive, right? So that's coming down on all new enterprises that have a certain power consumption. So all the building automation, ventilation, cooling, heating, lighting, everything has to be automated, completely automated. And I've seen with customers that I work with that are in the ocean ecosystem, the RFPs are spelling out it has to be battery-free, right? So smart building sensors have to be battery-free because of regulations. So on energy harvesting, I think I just want to sort of make the point, there's 4 sources of energy harvesting. It's light, it's movement of kinetic energy, it's thermal, and it's RF, right? RF is primarily RFID, and there's other sources of energy. We, as Dracula, focus on light harvesting, indoor ambient light, and we do that with organic materials. So we print organic materials on substrates that are completely flexible and recyclable, biodegradable. Whereas these usual solar cells that we all know that are sitting on roofs, pocket calculators are silicon-based, and they have a complete different performance, work very well with direct sunlight, don't work well in dark light. So why Dracula? Because we work very well in the dark. Look at market research, you can see that light harvesting is going to be the dominating source of energy harvesting. After that, you have vibration or kinetic harvesting, and thermal and RF harvesting. So that market will grow from 250 million last year to about 450 million euros in 2028. The other interesting point I want to point out here is if you look at this block here, smart building is the vertical that's going to benefit most of energy harvesting. And this is exactly where we come in, because if you look at the use case that I brought today to analyze the TCO, the use case is for a large enterprise, has deployed globally in 50 offices. It's an IT services company. I cannot disclose the name, but I've been working with them very closely in previous jobs. So they shared with me the data for this deployment, a LoRaWAN deployment. They started a rollout 4 years ago, and they're now in the midst of the battery replacement thing, right? So they know exactly the cost that comes with that. So I'll show you some numbers, and these are high-level numbers. I don't go down in the deepest detail. But you have the first cost is for the sensors, right? It's a huge cost. If you talk about 50,000 sensors, this is like, I guess it's like $2.5–3 million. The next cost is gateways and cabling. Then you got the software. Then you have the project management part and the deployment part, right? This is all CapEx. This is all the project cost to deploy a solution. It's very easy to calculate usually, and this is the case that you bring to your management for approval. The thing is, if you go on and you operate it for 10 years, if you do the math, how many swaps of battery have to be done in those 50 offices over the 10 years, and you just count the labor cost for crews going there, actually travel costs, everything, you end up with a significant portion of cost. Then, of course, the cost of the batteries, in this case, not the most expensive batteries. And then there's some other connectivity cost, and there's the usual maintenance IT cost. So that all adds up to the 100%. And of this, okay. So I was going to say, can I go back with this? Yeah. So the batteries and the battery swaps is about 30% of the total cost of ownership. Mind you, 30% of the total cost of ownership. It's almost as big as the cost of the sensors. So if you do the comparison of a solution which is completely battery powered, which they deployed now, and you do the math on an OPV, organic photovoltaics, the same products, you basically end up with 30% less TCO, right? So that's a real mind-boggling, it's underestimated sort of the hidden cost that can actually make or break the case. And I tell you, some of these large enterprises, they do the full cost analysis. Many smaller deployments, they don't look at this full 10-year deployment. Large enterprises, if they do the analysis and there's a CFO in the room, they'll do this, right? And they'll look at the total people cost. So you better get this right, and I tell you, the battery cost is killing the case. So on Dracula, I think what I want to say is that we're based on organic photovoltaics, so we print energy based on carbon material that we print on a thin film. It works very well in low light, so this is perfect for Dracula, probably 100 lux, maybe 200 lux. Think about outdoor, it's 10,000 lux, 20,000 lux, so it's really low light conditions, and this is typically smart buildings is the case. It's inkjet printed, so we can print any shape or form, and it works very well with LoRaWAN, it works well with Ocean, it works well with Zigbee, all low power protocols, Bluetooth, fantastic combination between energy harvesting and low power wireless protocols. And we just opened up our factory 2 weeks ago with the official inauguration. Huge production capacity. We can produce actually 150 million square centimeters this year, per year, and we can scale up next year to 300 million. And just to know this journey, we're here now after 10 years of R&D, right? So to develop this thin film foil where you can harvest energy from just carbon materials, it took us 10 years with $50 million euros from EU funds, French innovation funds, private investors, and it's a whole journey to get to this level here. We have a team of 40 people in Valence, in France, and we got 10 very prestigious awards that we won on innovation awards, CES, etc. Now, if you look at 2 use cases from the IoT space, smart buildings or asset tracking, the thing is that you see the light sort of situation. So if you're close to the window, you have 3,400 lux. But if you're underneath the desk, it's only 13 lux, right? So if a desk sensor, it has to work with very low light. Now, if you take industrial environments, again, you could have up to 4,000 lux, but there are also environments where you have only 280 or 500 lux. So the solution should be solid, robust, and work with very low lux. So our solutions work up all the way down to 5 or 10 lux. So it can continue harvesting in very dark environments and transmit whenever it's needed. And it could be once a day, it could be once an hour, or whatever. And we have a couple of customers that are already deploying our solution, like a temperature logger, PIR sensor on rooms, CO2 sensors. This is one I will talk about a little later. And this one is a smart label logistic application powered by Dracula. So this case, what I showed you before, this is a sensor that is an AI sensor, right? So it's detecting the stock in these vending machines. This is a Coca-Cola vending machine in the US, and they're rolling it out as we speak. An operator would have to go every day and check the stock and then refill, etc. They decided to use the sensor with this AI camera that feeds over wireless, which is Wi-Fi actually, that can do that trick. So it's real-time insight in stock based on the sensor sits on the door of the fridge and harvests enough energy to do the whole thing, AI and LoRaWAN. So we make the sensor autonomous. If they would have done it with batteries, it would be a non-starter because they don't want to change those batteries. Vending machines are all over the place. In America, it's just huge, right? So the only way to do this is with energy harvesting. Secondly, batteries don't love cold, right? So sitting on the fridge, the batteries wouldn't be having the best performance. So this is a good case where, again, where you marry wireless with battery-free. This is where you get maintenance-free IoT. We'll talk about it, right? Maintenance-free IoT or ambient IoT. I think this is where I basically believe that the lower TCO is the driver of this kind of solutions. And it's basically, if you want to do like connect and forget, we've been saying this for years, right? LoRaWAN, connect and forget. But then please eliminate the batteries, because as long as the battery's inside, you can't forget about the devices. You got to maintain them. So we can do any shape or size, form, any voltage, right? It's all scalable. Just a few examples of customers that we've done. And this is the latest and greatest. We just launched this product at the CES, and this is doing two things. It's harvesting and it's storing the energy. So on one thin film, on the front side, you harvest, on the back side, you just store it. So this is a game changer. Think about flexible tags and foils, smart labels. It will just do both. You don't need a super cap, secondary battery, or nothing. So, last thing here. I mean, as I said before, for Dracula, I'm in multiple ecosystems now. I used to be only in the LoRa ecosystem because I work with Semtech. We're now in multiple wireless ecosystems, and I tell you, they're much more advanced in adopting energy harvesting than we here in the LoRa ecosystem. I was last week at the N-Ocean Alliance. It's all energy harvested. There is no N-Ocean product on batteries. It's by design. The Alliance exists since 20 years. It's on the 865 megahertz spectrum, and it's all batteryless, right? So smart building RFPs that are coming out are asking for battery-free devices. It's N-Ocean, because LoRaWAN, there's too little devices that can work without batteries. RFID, by design, without batteries, right? Bluetooth, there's a company called Willits. They have energy harvested Bluetooth. Zigbee launched a new standard called Green Power. It's all energy harvested Zigbee, right? And then this is the latest and greatest. Ambient IoT is the 5G standard for energy harvested IoT. So these guys are making now really big steps forward to get into this mode of battery-free IoT. And I think this is my call to action for everybody in this room. If you're